I'm studying for the Burpsuite Certified Practitioner exam, and I thought I'd do a quick run through of Practice Exam 2, just to show off some of the ways to discover some of the vulnerabilities that you'll see on the practice exam, and talk through a couple different encoding methods for some steps, as well as some tips for utilizing ysoserial and SQL map that I have found useful on these exams. Let's start by loading the exam. Open a tab for the exploit server, do some poking around, see what we can do. It's an admin panel we can't get to. There's an advanced search function that seems to require a login. There's no comment functionality. The last thing I'll check before I switch to Burp is, does DOM Invader pick anything up? I like to enable inject canary into all sources. Come on. And we quickly find out that there is a eval sync here that is doing something with our search input. So if we click stack trace, we can see that it is here at this JavaScript inclusion. So we'll set a breakpoint on it. Let's see what we get. So there's our search term. I'm just going to disable inject into all sources now, just so it's a little less messy. We can see that's including our search term here as part of this eval string. Well, this is exactly what's getting passed into eval, so if we could mess with this and escape that string, we might have some fun stuff we can do. So I'll try to terminate the string and then break out of those curly braces, which seems to work. Cool, cool. Now, can we add a semicolon? We can. Cool, so now we can just pass something to alert, or something to eval rather. So we'll try to alert something. So we get potentially dangerous search terms. So there's clearly some kind of filtering on this. Is it alert that's pissing it off or something else? No. It's not alert the string. It's probably not the one. So let's try a JavaScript template literal instead of the parentheses. That doesn't get filtered. No, it doesn't. Does it execute? It does. Okay. So it's just parentheses that it doesn't like here. How can we steal cookies with this? Well, we have access to the log on our exploit server, so anything that's in the query string. Oh, no, it does show us the user agent. The header is cool. So let's just... Oops. Oh my god. Let's just try to get them to connect to our exploit server. This is going straight to alert, so maybe we can just do document.location equals, and then our exploit server. And it seems to only care about the parentheses as far as I can tell so far. There's, of course, this is randomized on the exam, including this practice exam. Sometimes it seems to care about parentheses, sometimes it's periods, sometimes it's whatever. So in this case, if it only cares about parentheses, as long as we're avoiding parentheses, we're fine. So I'll add a query string parameter and then see if I can add the cookie to it. Now I'll need to URL encode this plus, which is 2b from memory, but if you didn't know that, you would go to your friendly hackwriter here, put in a plus symbol, and then URL encode all. Yeah, 2b. So if I'm doing this right, I should get redirected to the exploit server. Okay, we'll step through that breakpoint. And I'm redirected to the exploit server with the session cookie in the URL. So that's perfect. Now if I check the access log on the exploit server, I should see that. Perfect. Okay. So now all I want to do is generate a CSRF payload from that. So go to burp. Here's the search results themselves, but I don't want that. I want the find parameter here. Perfect. So right click that, generate CSRF POC, and then for the actual exam, I find a good habit is to send anything useful to the organizer so I can find it later. And we will put this in as our payload. And I'll get rid of that breakpoint. Okay, and now if I view the exploit myself, really get rid of that breakpoint. Okay, that seems to work. So we'll just send that to the victim. And then check the access log. And deliver to victim. They hit exploit. There's their session key. Or the session cookie, rather. And hopefully it does include victim in the user agent string, so that makes our life a little bit easier. And now I'll just update my cookies to user stolen session cookie. And now when I click my account, oops, come on. There we go. So now I'm looking at Carlos's my account page. Just in case I break this, I will update the password. And is Carlos an admin? He is not. Okay. But there is an advanced search function that we can access now, since we're signed in as an authenticated user. So I'll just make a random search. Okay, so there's this JavaScript thing. Where is the advanced search? Filtered search. Okay, there we go. And I'm seeing a bunch of stuff here that looks like it's going to be part of a SQL query. So I'll send this to intruder. We'll select all the query parameters that we care about and hit auto, and we'll set a injection point on all those so that we can scan point insertion points. I'll do a deep scan. And then while that's cooking, we'll also send that to repeater and poke at it. See if we can get anything other than 200 or change the results at all. 5351. That's not giving us an error. Okay, so it doesn't like if I put a single quote in the order field. Oh, and helpfully it gives us the entire SQL query. So we see that we can inject right here. This is marginally annoying. I'm gonna find. Okay, there is a super old Portswigger page on SQL injection in the query structure, which is a little bit useful here. A database will not accept a union where or and at this entry point. Cool. But we do at least see the error message. So what can come after order by ascending, descending in the query string? I think you can do like limit 1. So we're getting, how many results do we get? I don't get any results. Okay. Maybe there's nothing matching foo. Okay, now I'm getting 1 result. Two results. Okay. Let's see if it picks anything up here. No, it's not seeing anything on our targeted scan yet, so we'll keep poking at it. Can I get an error out of this? let me just check my notes here and see if we can do a conditional error here of some sort. Just try to divide by 0. So this should succeed, and I should get one result. Perfect. Okay. So if this fails when I give it a condition that doesn't evaluate to true, like it gives me a divide by 0 error, then I know that this is getting evaluated, this inner query. Yep, perfect. So we see we're divided by 0. So now I have a primitive that lets me ask any Boolean question about the database. Anything I put in there. So if this is true, I won't get an error. If it's false, I will get an error. Now, we could start doing some substring stuff and whatnot, but this is annoying because I would need to know the name of the table, the name of the column, and then go character by character through it. Once we've got this far, we know, okay, we got a error-based Boolean injection here. I don't recognize the backend database yet, at least not from the error message. So this is where we go to SQL map. And I have a couple useful payloads here that I keep handy for SQL map. I used to give it a full request file using the -r parameter. I don't do that anymore. I find it doesn't work super great. At the very least, it's way slower. Now I just use the -u parameter. So we'll go Python. Then we'll give it the same cookie that we're using. I found if I don't use the lab cookies, I can have all sorts of problems. And also we need the stolen user cookie to even access this filtered search function. We do know that the injection is in the order parameter at the end of the URL. I can find it. Yeah. So we'll tell it to inject in the order parameter. We'll give it a delay of 0. If I can type properly, which I apparently can't. Timeout of 30 seconds. Retries 0. Level equals 5 because we don't care about knocking this over. Same with risk equals 3. For proxy, again, I found issues if I don't proxy it through Burp for whatever reason that is. Give it a random user agent. Tell it to use the default settings instead of asking me for stuff. And then we'll tell it to dump. Okay. So we get this clicking while we continue poking at it. Oh, whoops. 1 dash for that. Okay, heuristics say it's not injectable. It most definitely is, because we can get it to evaluate whatever's in here. Let's see if Burp's come up with anything yet. Oh, it has. It recognizes the error format as being Postgres, so we can make this a little bit faster by telling it that it's Postgres. And actually, we can go a step further by using technique, and we know it's error. That's an error-based injection. I'll do blind as well, just for shits. So this should be a little bit faster, because it's not going to try every database format. It's not going to try every technique. It's specifically going to do error-based and blind. And while I'm doing that, I will also check for any of the Portswigger labs where I had to go character by character through a blind error-based injection. Let's see. Blind SQL injection with time delays, out-of-band indirection, visible error messages. Yeah, SQL map I found is not super reliable for, if I just gave it this query string and said SQL map, find a SQL injection in this, it would take forever and it might find it. I find it unreliable. But once I get to the point where I can generate an error based on a Boolean condition or something and I give it the exact parameter, then it tends to be quite fast. By quite fast, I mean within 5 to 10 minutes. So let's just wait and see what it gives us. Okay, it thinks that it's Postgres, so we'll assume it's right for now. I think it's table underscore name in Postgres as well. Yeah. Go character by character and see if we can. Well, this condition to be embedded in this. Pick somewhere in the middle of the alphabet. Nope. What I'm trying to do here is get the first character of the name of the first table and then compare it against somewhere in the middle of the alphabet and see if I can get an answer to what the first character of the table name is. Might also be an encoding issue. So let's just URL encode this. Yeah, so I start SQL map early. Okay, perfect. SQL map's already got it by doing some complicated casting. Cool. Let's find the public database. Okay, there is a users table. No randomized name here, so let's start by dumping that. And it's in the public database. So we'll give it -d public database t users in the database. And it should start dumping the users table. Any second. There we go. Cool. Yeah, perfect. Cool. We have 3 users in this database. One is an administrator, there's Carlos, and whatever the hell that is. So let's see if we can sign in with these dumped credentials. We'll log out. Perfect. And again, just in case I lock myself out, change the password. And now, cool, now we can reach the admin panel. And there doesn't seem to be anything super useful here that I can see. The only thing we can do is delete users. I don't want to delete users, at least not yet. Because I can only do that twice. There's only 2 users in here. I mean, I could, with the SQL primitive here, maybe add a user to the database, but let's just play it safe. I will turn on interception. I'll delete this guy who's not Carlos. And here in Burpsuite, we get a request, which I'll just send to repeater, and I'll just drop it. Because I don't actually want to delete a user here. Okay, and we'll go back to the admin panel. And let's take a look at this. Okay. Cool, you give it a username parameter. We got our session token for the, or session cookie rather, for the admin account. And then this looks interesting. Anytime I see H4S, I'm thinking Java deserialization. Fortunately, we have the HackRotor extension installed, so I'll Control-Alt-D to smart decode it. And yes, this does look like a Java object. Moreover, we can see that it's URL encoded, of course, base64 encoded, and gzip compressed. So whatever payload we give it will have to be gzipped and then base64 encoded. But this is definitely a Java object. So I'm just gonna, so I don't accidentally delete a user, change the username here. And let's start looking at some insecure deserialization. So if the backend is actually reinstantiating this object, this Java object that's stored in this admin press cookie without checking anything else, we might get lucky and we might not actually have to give it a real user to delete, assuming it reinstantiates this object first. So let's just hop into ysoserial. And in the Portswigger labs, you'll probably see a note on the insecure deserialization labs about doing something like this if you're using Java 17 or higher. Even this isn't reliable. Honestly, seriously, just download the Docker image and do it that way. And we know from the, what's it called, from the lab text that for step 3, to prove we have root access, we want to read this specific file. So we're just going to go through everything that's in ysoserial, starting with CommonsCollections, because we know it definitely does have, I mean, it almost always will have CommonsCollections. Let's see what payloads we have in ysoserial. If I can get Docker to run. Go on. Oh my god. Okay, weird. The only reason I'm doing this in Windows Subsystem for Linux is because Linux has gzip and base64 on the command line already. Okay, cool. So now it's working. We'll give it a command, curl-d to make a post request with the content of this file. And the second argument will be where we're sending it. You could send it to the exploit server, but I just use Burp Collaborator for everything. Okay, and that should give us